The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: 4-digit dividend and 3-digit divisor involving zeros in the dividend and the divisor. Example: 9100 divided by 606. We had mentioned in several places that involving zeros in any mathematical operation is not complicated, but attention is necessary to have the right placement of the zeros. And at times, you should not miss the column placement too, especially when the problem is solved using abacus, which is tactile in nature. Let us take the example 9100 divided by 606. Let us set the dividend 9100 in the right extreme of the abacus and set the divisor 606 in the left extreme of the abacus. The child should not be tempted to guess that the remainder will also have zeros by looking at the two empty columns at the right end of the dividend. As 6 is smaller than 9, we have to skip a column in setting the quotient. We ask how many 6's in 9. By saying 1, we cannot reduce it further. And as we had mentioned earlier, in such occasions, 1 should be treated as the assumed quotient. Let us set it to the left of the dividend by skipping a column. Now multiply 1 with 606 and subtract it from the highest 3 digits of the dividend, that is 910. 1 is multiplied with 6, which is 06, that is 0 subtracted from the 10,000s column and 6 subtracted from the thousands column. In the next stage, 1 is multiplied with 0, that means 0 subtracted from the thousands column and the next 0 subtracted from the hundreds column. This procedure is important as the next operation should start from the hundreds column. Now multiply 1 with 6, which is 06, that is 0 subtracted from the hundreds column and 6 is subtracted from the tens column. As there is no 6 available there, we simply subtract 1 in the hundreds column and add 4 in the tens column. At this stage, we are left with 3040 in the dividend, that is 3040 in the dividend. We are into the second stage of division. Now the highest digit of the divisor 6 is larger than 3 of the dividend, and therefore there is no need to skip a column in setting the next digit of the quotient. As 6 is larger than 3, we have to take the first 2 digits, that is 30. Now ask how many 6's in 30. By saying 5, reduce 1 from there and set 4 as the assumed quotient to the right of the already set quotient 1. Let us multiply 4 with 606 and subtract it from 3040. Let us start the multiplication now. 6 multiplied by 6 is 24, that is 2 subtracted from the thousands column and 4 subtracted from the hundreds column. We can't do that, and therefore subtract 1 in the thousands column and add 6 in the hundreds column. Next we have to multiply 4 with 0, that is 00, and therefore the next operation should start from the tens column. Let us multiply 4 with 6, that is 24, that is 2 subtracted from the tens column, and 4 should be subtracted from the units column. As we can't do that, subtract 1 from the tens column and add 6 in the units column. Now check the remainder and the divisor. The remainder is 616, which is greater than the divisor 606, and therefore we have to make an adjustment in the quotient. That is, add 1 to the quotient, that makes it 15, and subtract 606 from the remainder, that is 6 in the hundreds column, 0 in the tens column, and 6 in the units column. As the divisor is a 3-digit number, the 3 right extreme columns are for the remainder. There is no bead in the units column, 1 in the tens column, none in the hundreds column. That means the remainder is 10, and the quotient is 15. You must have noticed that extra care was necessary in treating the place values of zeros, as missing even one column will lead to faulty result.